In the last lesson, we took our very simple YOLO node, our very simple ROS2 YOLO node, that all it was doing was showing us some annotated frames by using an OpenCV window. And we turned it into what began to be a more realistic pipeline, because you don't really open an OpenCV window from a ROS2 node. That's not necessarily a good practice. So the first thing we did is that we published the annotated image into a new topic of type image. And then we were able to look at that stream or see that stream from RViz. And that's good for debugging. And that's the right thing to do. That's why we did it. And it allows us to still have that annotated frame for debugging purposes, so that we, the human operators, can see what the robot is seeing and see if the YOLO pipeline is working fine. But in order for this to be a more useful computer vision pipeline, we actually need to publish the raw detections. And by raw detections, I don't mean the image with the bounding boxes on it, but the actual dimensions of the boxes, the positions of the boxes, the labels of the objects detected. Post that as a raw text somehow. Publish it through a topic, so that other downstream tasks can be executed. So other nodes will subscribe to these raw detections. We'll get all these bounding boxes, dimensions and positions and labels, and do something meaningful with it. And meaningful things could be like classic, very classic in robotics, like object collision avoidance. Sorry, see objects and avoid them. So collision avoidance, tracking, like if you're following something, if you're following a person or you're following a target, so you wanna keep tracking that bounding box. You want to see this box from the previous frame is the same as the one in this current frame, so keep track of it and follow it. Or just simply have a database of all of the events that occur during the drive of the robot, or in this case, all of the things that you saw during the drive of the robot. You could very easily just store all of this information in a simple database for later querying. This could be good for safety, right? Like if there's an accident, you want to see what kind of object was around the robot when the accident happened, stuff like that. So the first thing we're gonna do today is we are going to run the demonstration. Obviously, we always start with the demonstration, and then we're going to talk about vision messages, which is the type of message that we are going to use to publish this information. So before we talk about vision messages, let's just run the demonstration quickly. So here, so always remember to run the good corresponding commands from the correct folder. And then here we are going to source, assuming that you already built the workspace where our code is, and then we're gonna run the code. So now it's version 3 of our node, and notice this time when it loads, it will tell you the classes, right? So it needs to know the classes, because YOLO just gives you a number, right? Whenever it detects an object, it will give you the number of the class. But we might want to actually publish the actual English word for that label. So now we have access to that, and just for showing that we're ready, we're printing the labels here. So here we are going to prepare. So we need to source the ROS workspace. So here we are going to get ready for playing the back. So we always go one level of folders up, so to where the bag is. Attach another terminal, and here the same. We need to source the ROS workspace, and we should probably also source our working workspace. And then here's where we can do it already. We're gonna run RViz, and we're gonna open the correct configuration file. So we kind of like the same things we did last time. It's good to repeat sometimes so that it's easier to remember. Repetition is good. Not always good, but often good. And here we're just gonna find the correct word. Yeah. By the way, there are ways to automate all of this, but out of the scope of this course for now. Okay, RViz is ready. So now let's play the back. To back play link code dash something. This will immediately start playing, and as usual, this is the original frame. So just like we did last time, we probably want to see the annotated version. So this is the original that came from the Z camera. Now this is the annotated version that we started publishing from the previous lesson. And again, this is good for debugging to see, okay, YOLO is running correctly, it's doing the right thing. Now, the new version of the code is actually publishing the dimensions and positions of all of these boxes with the label and the scores. And we can see that, let's see, we need to attach, and we need to source the browse workspace. Okay, and then this normally should work, but browse to topic list, and there it is. So detections raw. This is what we are publishing now from the new node. And then if we do something like ROS2 topic info detections raw, so this will tell me that someone is publishing it, which is the YOLO detector node 3. We haven't subscribed to it yet, which makes sense, right? We started publishing. In the next lesson, we will subscribe to this topic and do something with it. But for now, it's just been published. And here is a type of message called vision messages detection to the array. Okay, so it's an array or a list of two-dimensional detections. Okay. So it's working. Now let's publish it and see what's inside. It's gonna look very messy because it has a lot of fields, but we can echo it. And maybe I should probably make this window a bit larger. So you see, it's gonna post a bunch of them. So for now, you see there's a hypothesis, which a class ID, traffic light, there's a score, very low score. You can change that actually to, there are many detections that should not be actually considered detection because they're too low. So you can change the score. And here, this is the pose of the object. And we don't really have the pose, right? Because we are not doing pose estimation. But what we do have is the bounding box. So here's the center of the bounding box, and here's the size. Right, so this allows us to determine where the object is in the image, its position, and how big the box is. And from the box, we can infer how big the object is. And there will be, remember, this is an array, so there will be one such detection for every object detected in the image. Now, it's not very obvious here, so it's very hard to read this output. But we're gonna subscribe to it and do something more useful with these detections. So let's look at the code. It's here, and we're gonna go straight to the differences. So the first thing to note is that we are importing, by the way, let me stop this because it's slowing down my, stop all this. So the first thing to know is that we're importing from the vision messages package, we're importing a bunch of new data types. So detection to the array, detection to the object hypothesis with pose, bounding box to the pose to the and point to the. Then we are creating a new topic out name, topic out detections, right? We are publishing one extra thing. And as such, we also need to, by the way, here we're getting the model, but we're also getting the class names. So from the model itself, the YOLO model, we get we use the dot names attribute, and we get the class names so we can print them. And we're ready to put those into the detections. Then we create a new publisher, the detections publisher. It's not an image, it's a detection to the array. So remember, is a list of two-dimensional detections. And then we just log everything for debugging. And here in the image callback, everything is almost the same, right? We do the inference, we convert the ROS2 image into a computer OpenCV image. We do the inference on the OpenCV image, we get the results, we plug them. Then before we can publish that annotated image, we do the reverse conversion, like we go from OpenCV image to ROS image, we publish it. And then here's the new stuff. We're going to publish the raw detections. So we start by creating a new message of type detection to the array, right? So it's the detections array. We put the header to it, which is the same header. This is the message that original of data, the original camera images coming from some camera. So it has the header. The header has the name of the frame for that camera, and we use the same frame, right? Because the data is coming from the same sensor, although we're processing it, but it's coming from the same sensor, the original input data. So we use that same header. And then if the result, this is the YOLO result, if there are boxes, if there are bounding boxes in it, or if it's not none, it's the same thing, if we have detections, then we will extract the boxes, all of them, the confidences or the scores, and the labels. And then for every box, right? So we in this loop we go over every box, and we get the dimensions. Okay, so the min, x min, y min, x max, y max. So this gives us the two corners of the box. Okay. And then each box is a detection to the, remember the whole thing will be a detection to the array, but each individual box is a single detection, a single two-dimensional detection. It also needs to have a header, which is the same header of the original data. And then we create a bounding box, okay, that we will put later inside of this detection to D. So we create a new bounding box to D. And then we compute some, we need to create another thing, sorry, for the bounding box. The bounding box will have a center point, and the center point is a point to D, right? So it's confusing. You have to go through this again. So the bounding box will need to have a center. Actually, we'll see that later, don't worry. So the center it has to be a point in two dimensions. So we create a point to D. And then the center of that will be, remember, this gives us the corners of the image. So to calculate the center, we need to do a little bit of math. So it's the x min plus x math that gives us pretty much the width of the image. And so we divide that by 2, and that gives us the center in that direction. And then we do the same here, y min, y max. This gives us the height of the image. We divide that by 2. Not the image, sorry, of the bounding box. We divide that by 2, and that gives us the center of the box. So now the bounding box center's position becomes that point, okay? And the size of the box becomes this, right? And here is divided by 2 for the center, but here it's not divided by 2, so it's actually the dimensions. And now that we have that bounding box 2D, we can add it to the detection to this BB box attribute, right? So this is a detection 2D that has a bounding box. So it becomes this box here. Now we also need to create a object hypothesis. So we create an object hypothesis with pose. The class ID will be, well, there's a dictionary of class names that maps the number, or the class number returned by YOLO to a class name. So that we extract that class name from this mapping, right? From number or from ID to class name, and then we put in class ID. Then the score comes from the confidences indexed at I, right? Because we are looping over the boxes, and the confidences have the same dimensions, and we're getting this I here. So we're looping, we use that I to extract the corresponding score or confidence level. And then after we have created that object hypothesis, the bounding box 2D, oh, sorry, the detection 2D object, in the results section, we append that hypothesis. And then we append that bounding box 2D to the bounding box 2D array. Okay, so again, we start with an empty bounding box to detection. Sorry, I keep saying bounding box. Sorry. We start with the detection to the array that is empty. We go over all of the detected boxes, and for each box we create a detection to D. We need to give it a bounding box to D. We need to give it a hypothesis, and then we add that detection to D into the detection to the array. And then once the loop ends, the detection to the array has all of the data, and we publish it. Okay, so that's it. That's how it works. Now, you might have to go over this again, because the first time it can be very confusing. I want to mention two things. First is by default, ROS2 doesn't come with this pre-installed. This is it's not a standard ROS2 message. You can think of it as a custom message, but someone else built for you. You didn't have to do it yourself, but you need to install it explicitly. So two important things here. If we look for ROS2 vision messages docs. So which one is the right one? Probably this one. I mean this. This is the repo. Yeah, so this is the official repo. So I mean you could download the code from here and build it yourself, but you don't really have to do that. But here, see, even in the reference, YOLO is the very first one. This is definitely for computer vision. And then the documentation. Let me see if I type humble. I had it earlier. Maybe it's here. Yeah, it's this one. So here you can see the definition of all of these data types. So for example, we were talking about bounding box 2D array. There's a 3D array for like LiDAR and 3D data. So if you go inside, you can see that it has a header and it has a list of bounding boxes 2D, and then you can inspect more easily what's inside of each of these fields. So like a bounding box 2D, if you go there, you see that it needs a center, which is a pose 2D, and then it has the sizes. So if you go to pose 2D, is here, you see that pose 2D needs a position, which is a point 2D, and a theta, which we didn't use, because it's for orientation, but we don't have orientation. But we do have the position, and it's a point 2D, and if you go to point 2D, it's just XY coordinates of that point. And so yeah, go ahead and inspect this. And the next thing I wanted to show you is that ROS2 vision messages install. It will not come by default with ROS. You'll have to explicitly install it. So okay, here in the AIs, perception. not sure you need to do that. Same humble vision right here, maybe. So I think it's this Ross humble vision messages. Anyways, so here, if I try to install it, apt install. I think I need to remove the 2. No, it's yeah. So if you see it, I have it already. The Docker container that you're running already has it. I put it there for you, but normally you would have to install it. It doesn't come by default with ROS 2. So that's what I wanted to say. So in this lesson, we are moving towards our more useful computer vision pipeline. We are now not only publishing the annotated frames, which is good for debugging from RViz, but we're also publishing the raw detections, which is what will turn this whole thing more useful, because now some other node can subscribe to the detections and do something like collision avoidance or target tracking, or just simply keeping a database of everything we've seen for safety issues. So in the next lesson, we're going to do just that. We're going to create a node that will subscribe to this and just keep a track of everything we've seen, and just give you a very small summary of everything we've seen so far. It's very simple, but it illustrates what an actual pipeline should look like. So see you in the next lesson.